Hi, question number 4 taken from October 2015, Advanced Level Maths HSC P3. The equation x cubed minus x squared minus 6 is equal to 0 has one real root denoted by alpha. First part, find by calculation the pair of consecutive integers between which alpha lies. Second part, show that if a sequence of values given by the iterative formula x sub n plus 1 is equal to root of x sub n plus 6 upon x sub n converges, then it converges to alpha. Also, for the third part, use this iterative formula to determine the value of alpha, that is alpha, correct to 3 decimal places. Give the result of each iteration to 5 decimal places. Okay. So let's do it. Now, for a question like this, okay, let's begin by getting the information right. We need to find the two consecutive integers between which the value of alpha lies. The equation is x cubed minus x squared minus 6 is equal to 0. It has one real root, and that real root is denoted by alpha. So how are we going to find out? Of course, if it lies between two consecutive integers, suppose your curve looks something like this. Now, one value of x here, okay, let's just say a, and then you'll have b. These are the two values we need to find out. And when we substitute a into the equation here, it has to give us a negative value. So suppose this is going to come here, a negative value. Alright, and then when you substitute b, it has to give you a positive value somewhere there. So between a negative value of y and a positive value of y, so we're going to have to find out these two consecutive integers. So the root will be somewhere here, right? So what can we do? If we put a 0 here, we can clearly see 0 to the cube minus 0 to the square minus 6 and give us to minus 6 anyway. So let's try minus 1. What about let's just try 1. 1 to the cube is 1, 1 minus 1 is 0, 1 minus 0 minus 6 is minus 6 again. What about minus 2? Sorry, what about 2? So if we put 2 here, let's just say f2, I'm going to end up with 2 to the cube, which is 8, minus 2 to the square, which is 4, minus 6 is equal to, so 8 minus 4 minus 6 is going to give us minus 2. Let us try f3. That's going to give us 3 to the cube, which is 27, minus 3 to the square, which is 9, minus 6. So we have 27 minus 9 minus 6, and that's going to give us 12. Okay, clearly this is a negative and this is a positive. Alright, so the values are 2 and 3. So these integers are x is equal to 2 and x is equal to 3. Here we are for the first part. Now for the second part, we need to show that if a sequence of values given by the iterative formula x sub n plus 1 is equal to the root of x sub n plus 6 over x sub n. We need to show that if we have a sequence of values given by this formula, then it converges to alpha. So we're going to have to prove this formula. How are we going to do this? We're going to use the original equation, x cubed minus x squared minus 6. So if we put this down, x cubed minus x squared minus 6 is equal to 0. What I can do here, I can send the okay, first of all, I can send minus 6 on the other side. So I got x cubed minus x squared is equal to 6. You can factorize this. Maybe you can say x outside, and you got x squared inside minus x is equal to 6. And of course, x squared minus x is equal to 6. The x goes on the other side, it divides. We can send the minus x on the other side, so we have got x squared is equal to minus x, it goes on the other side, becomes plus x, plus 6 over x, and hence we have x is equal to, you take away the square, and you're going to end up with square root on the other side. So x plus 6 over x, and here we are. It has been shown that it will converge. Okay, so this is the second part of the question. Now, for the third part, we need to use this iterative formula. Okay, and we have to find the root. Okay, and we need to give the result of each iteration root to 3 decimal places, and we have to give the answer to 3 decimal places. I mean, give the result of each iteration should be to 5 decimal places. Now, first of all, what is very important and what we need to understand is we have to get an initial value of x. Now, x was 2 and 3. What I can do is 2 plus 3 divided by 2. So I can take this as the initial value of x. Okay, so this is 5 divided by 2 is 2.5. So my first value here, I'm going to say x is equal to, let us say this is x 0. So 0 plus 1 is 1. And we're going to get the square root of 2.5 plus 6 over 2.5. Okay, so if we do this on our calculator, so we got 2.5 plus 6 divided by 2.5, sorry, and then we're going to have to get the square root of that. Square root of the answer is going to give us 2.21359, the 5 decimal places. This is the first iteration, 2.21359. 2.21359. 1, 2, 3, 4, 5 decimal places. Okay. Now the second value is going to be x is going to be 2.21359 plus 6 divided by 2.21359. Okay, so 6 divided by 2.21359, okay, then plus 2.21359, and the square root of the answer is going to give us 2.21904. So 2.21904, 5 decimal places. Okay, and then we have x3, 2.21904 plus 6 divided by 2.21904. Okay, 6 divided by 2.21904, okay, plus 2.21904, and the square root of that is going to give us 2.21876. 2.21876. Okay, so clearly, before I jump to any conclusion here, okay, let me just try one more value. So x4 is going to be square root of 2.21904 plus, oh sorry about that, 2.21876 plus 6 divided by 2.21876. Okay, 6 divided by 2.21876 plus 2.21876, and the square root of the answer 2.218777. Alright, 2.21878 8, let us say. Alright, now all this is converging to 2.21, therefore alpha is going to give us 2.21. And here we are for this question. That's the answer.